Namaste. This video will showcase some important mathematical tricks that are quite helpful in evaluating characteristics of squares and square roots of natural numbers. By the end of this video, you will be in a better position to explain what is meant by squares and square roots, and at the same time, you will also learn some interesting facts and patterns coming up while studying squares and square roots of natural numbers. So let us give it a go. Introduction. The first question in your mind should be, what is a square and what is a square root? In simple words, a square is obtained when a number is multiplied by itself. For example, when I multiply 3 with 3, I get 9. So in this case, 9 will be called a square of 3. I can also write it as 3 with a superscript of 2 equal to 9. Here the tiny 2 you see in the superscript says that two 3's have been multiplied together, and you read it as 3 square is equal to 9. Other way round, I can also read the relationship 3 multiplied by 3 equal to 9 as 3 is the square root of 9. And this will be represented as 9 with a square root of sign equal to 3. Saying that 9 is the square of 3 or 3 is the square root of 9 means have the same meaning. It's just a different way of saying the same thing. Now you saw that for 9 we were able to find another natural number 3 which when multiplied with itself gives 9. Is that the case with all other natural numbers? To understand this, let us take two consecutive natural numbers 5 and 6. What are the squares of these numbers? Square of 5 is 5 multiplied by 5, which is equal to 25. And square of 6 is 6 multiplied by 6, which is equal to 36. So for 36, we have a natural number 6, which when multiplied with itself gives 36. And same is the case with 25. But what about the numbers lying between 25 and 36? There will be several such numbers. I will take one of them, say 30. Can you find a natural number which can be called square root of 30? Obviously, since 30 lies between 25 and 36, its square root should lie between square root of 25 and square root of 36. That is between 5 and 6. And we know there is no such natural number between 5 and 6. Therefore, I can say that there is no natural number which when multiplied by itself gives 30. Such numbers which do not have a natural number as their square root are called non-perfect squares. And numbers like 25 and 36 which have natural numbers as their square roots are called perfect squares. Therefore, any natural number is either a perfect square or a non-perfect square. In subsequent parts of this video, you will see some important facts and patterns related to squares and square roots of natural numbers. To begin with, I will just note down the squares of first 10 natural numbers. Square of 1 is 1. Square of 2 is 2 multiplied by 2, which is 4. Square of 3 is 9. For 4, it is 16. Square of 5 is 5 multiplied with itself, which is 25. Square of 6 is 36. For 7, it's 49. For 8, it is 64. Square of 9 is 81. And the square of 10 is 10 multiplied with itself, that is 100. This is how the square of first 10 natural numbers would look like. Let us now note down some important observations from this list. Please pay particular attention to the last digit in all these squares. We have 1, 4, 9, 6, 5, 6, 9, 4, 1 and 0. So what do we see? We see that all squares end with 0, 1, 4, 5, 6 or 9 at units place. None of them have 2 or 3 or 7 or 8 at its units place. That's interesting. But how is it useful for me? It's useful because the last digit is the most easily predictable digit in squares and square roots. If you need to predict the last digit in square of a 10-digit number, then going for multiplication will be tedious and time consuming. Easier approach will be to look for the last digit of the given number and square it. The digit at units place in this square will be the last digit in square of 10-digit number. That's how you can save quite a lot of time and effort. There is one more use of this observation which you will realize while we solve some problems. Other few obvious observations are: square of 1 and 9 end with 1 at units place. Square of 1 and 9 end with 1 at units place. Square of 2 and 8 end with 4 at units place. Square of 3 and 7 end with 9 at units place. And square of 4 and 6 end with 6 at units place. The easiest one is that square of 5 ends with 5 and square of 10 ends with 0 at units place. Now with all that said, what's the easy way to remember it? Last digit in squares of 5 and 10 are the same as that in the number itself. For 5, it's 5, and for 10, it's 0. So I believe you can remember it easily and cover it for the time being. For rest of them, just remember the year 1496, 1496. You remember lots of years in history, just remember one in math as well, 1496. How is it useful? The trick I use is, in this setup, take the first from the top and the first from the bottom. Squares of both of them will have 1, that is first digit of 1496, as the units digit of their squares. After that, take second from the top and second from the bottom. Squares of both of them will have 4 at units place. Take third from the top and third from the bottom, square both of them, and you will have 9 at units place. And finally, take fourth from the top and fourth from the bottom, you will have square them and you will have 6 at the units place. Now let us see how can we use all this information in solving problems efficiently. Here is a question. will following numbers ever make a perfect squares? So we have been given 4 numbers and we need to make sure which one of them makes a perfect square and which one doesn't. Now perfect square means there exists a natural number which when multiplied with itself gives this number. Any natural number will of course end up with a digit between 0 to 9. And we have seen that a square of all such numbers cannot have digits 2, 3, 7 and 8 at units place. So just by looking at the digit at units place, we can straight away infer if the given number can make a perfect square or not. Take up the first one, 4137. What's the last digit of this number? It's 7. Can it be a square of any natural number? No, because there is no natural number whose square will end with 7. So definitely this is not a perfect square. Let's take another one, 1296. Can it be a perfect square? The number ends with 6 at units place. So it may be a square of a natural number ending with 4 or 6. I'm still not sure if this is a perfect square, because all numbers that ends with 6 are not perfect square. Simple example is 26. It ends with 6 but still not a perfect square. So I will say it may be or may not be a perfect square. Look at the next number, 81652. Once again, a number that ends with 2. Can it be a perfect square? No, it can never be a perfect square. And by the same argument, the number 9, 9, 9, 9, 9 and 8 can also not be a perfect square because it ends with 8. Let us take another question. What will be unit digit of 224 square, 3453 whole square, and we have 2 other large numbers whose squares are given. Notice that in this question we are not being asked to calculate the square. Indeed, we just need to calculate the unit digit in the square. Calculating the square will be tedious and time consuming. In order to predict the unit digit, we shall use the trick that we learned a while ago. What is the unit digit of 224? It's 4. And what is the unit digit in square of 4? It's 6. The square of 4 is 16 and its unit digit is 6. So unit digit in square of 4 is 6. Now what will be the unit digit in square of 224 or any other large number that ends with 4? It will always be the same as the unit digit in a square of 4, that is 6. Similarly, you can predict the last digit in a square of 3453. It will be same as that in the square of 3, that is 9. For 99999, the square will end up with the same digit as the square of 9 ends up with, that is 1. And by the same argument, for a square of 7841342, all we need to calculate is the square of 2, which is 4. And we can straight away say that the square of this large number will end with 4 at its units place. So you see how easily we could calculate the unit digit in square of such large numbers without actually calculating the square itself. Thanks for watching this video. If you found it helpful, please subscribe to my YouTube channel and stay updated with more and more upcoming videos on various topics of mathematics that will be extremely helpful to school-going students and aspirants preparing for various competitive examinations. With all the best wishes, thank you once again.